Nix Vegas. We're coming back with another talk by JB, and he's going to talk to us about NixOS Workspaces and how to partition up your remote development environments.
Hello, Nix Vegas. It's good to be back. All right. Today, I'm going to be talking about just a little pet project, a little convenience function over what are called Nix containers or NixOS containers in order to partition development environments remotely. All right. So before I continue, just a very quick tidbit about myself. I currently work for Microsoft as a security engineer. I work mostly in static analysis and application security. And previously I was a pen tester. And I've been a proud NixOS user since 2023. And I've never looked back. All right, so our story actually starts just a couple of months ago when I took a little vacation down in Joshua Tree. And so I drove from Vegas. Well, me and my partner drove from Phoenix down to Joshua Tree and stayed at a nice little Airbnb. And it was really quite remote. It looked like this. This is my first time in an American desert, and I didn't know exactly what to expect in terms of, I guess, reception. But it wasn't good. It was not good. And being the Nix addict I am, and the proliferation of agents at the time, I think this was just shortly after February, when Claude and its associates really took the world by storm. I started spinning up my own services and porting its proprietary stuff into home lab services, and so I couldn't give my addiction up on my holiday. And so I booted up my laptop and I tried to build one of my projects, and I was greeted with a call out to Nix packages, and the bandwidth at the time was really not up to par. It really struggled, and it just could not facilitate what I wanted. So this is kind of reminiscent of what it was like. The internet is so damn slow. It's reminiscent of dial-up speeds. You get that kind of jittery line by line loading. It was just not workable. So the situation was I was extremely remote. I had a very poor low bandwidth connection. And I also had low compute in terms of my laptop. This thing is 10 years old. It's not exactly modern, but it works fine. But at home, I've got much better services. I also, however, have a Tailscale connection out to my home lab, and that is going to come out very handy. So what the network looked like, or what the network I was using, was I've got my connection to my laptop, and over WAN, I'm accessing my home lab and my internal services. So I've got a build server, I've got a Nix store cache through Harmonia or some other similar service. I've got a group of other internal services that I use, and my home lab has a really great processor and hardware, and it's got a great high-speed fiber connection. The problem is I'm accessing it all over my crappy desert internet. And so this is the real problem. These connections out here syncing back and forth, blobs of Nix packages and built things, as well as calling out to wider Nix packages and downloading external stuff. And so I really had to do something about this. I could not let my addiction be impeded by some crappy little internet connection. I needed to think outside the box. And so what was my idea? Well, I got to move my operating environment into my home lab and then access that remotely. So I can fully capitalize on the fiber connection that my home lab provides, the Nix build machine, which is on like an Epic processor, my Nix cache with pre-built packages and everything, and much higher compute than my measly laptop can bear. And so, earlier last year, I bought a really nice, juicy AMD EPYC processor. It's got like 64, virtual cores essentially, and it has never let me down so far. It's been absolutely extraordinary, and it's very, very power efficient as well. It's a strong recommend, strong recommend. And so, how are we going to do this? Is essentially we've got a dev box. We've just got a machine inside of our home network provisioned over Proxmox or something of the sort. And then we could just SSH into that dev box over my crappy internet connection. And then the bandwidth can facilitate that, because all we're really syncing between my laptop and the dev box is just a series of keystrokes, some terminal sequences, buffer my terminal and that kind of thing. And then I'm free to use all of my internal services, free to use my high-speed fiber home connection, no problem whatsoever. And so that worked. That worked for a while. If you're a tmux user or a ZLEJ user, you might be very familiar with this setup already. If you're not familiar, tmux or ZLEJ is a terminal multiplexer. And what essentially that means is you've got a series of virtual terminals inside of one terminal. And so they're just like windows that you can then control, partition, and group. And, you've got multiple terminals within a terminal. It's a very, very convenient thing. Now, tmux specifically, and ZLEJ as well, support some nice features around attaching and detaching. So you can create a workload or create a development environment. And then when you're done, or when you need to pause, you can just detach from that environment and then, close your laptop lid or whatever, or set some process to go. Close your lid and then revisit it in 2 hours, and everything is still been executing all that time. So it's perfect for like agentic remote development use and that kind of thing. But yeah. So we've got a win. We've got we fully leveraged all of our self-hosted services, and we're not really constrained anymore by our slow network. We've essentially kind of like compressed our usage of the network into just the terminal escape codes and terminal buffering. And as I said, we do terminal multiplexing by tmux or ZLEJ. But we've got a problem, because I'm sure many in the audience also do this, but you've got multiple concurrent things that you're working on, kind of like very ADHD-like, and everything's shiny. The next thing you think of, you want to jump on 100% and just kind of like put everything to the side. And so you'll have multiple pans on the fryer, so to speak. So we've got multiple concurrent workloads. And if we're using agents or anything, they will frequently like fight over the same ports and things. And so what we really need is some kind of isolation primitive to use. And so, yeah, we'll have agents that are kind of like, trying to utilize the same ports and services, and maybe even we'll step on each other's toes in terms of file system. And we want to prevent that. We really don't want any contamination between them. And so what we need is some kind of containerization technology, right? So we want multiple workloads to not conflict over common ports like 8080 or 443 or 80 or whatever. So can we use Docker to separate our development environments in a Nix-friendly manner? Well, yeah, kind of, maybe. But there are a few caveats. So if you just, very naively use a Nix image, you'll end up with duplicate Nix store entries, and that will blow up your container image size, like very, very, like it'll be untenable. You'll consume your memory very, very, very quickly using that. We could possibly, mount Nix store, but that opens up a host of issues. Like, that could corrupt the host's store, and then if you do garbage collection on the container, which then interrupts or removes packages from the host NixOS, machine that it depends on, well, then you're going to end up with a malfunctioning device, and we don't want that. So we need something better, more Nix native, and thankfully there actually is a very nice, convenient thing for that. They're actually called NixOS containers, funnily enough. But what's really important, or what's really nice about them, is they're just dependent on systemd-nspawn containers. And everyone here loves their declarative formats and everything. And so you can declare systemd-nspawn containers in a very Nix friendly way in a flake or, Nix configuration file. And so here we've got just a configuration example of a web server. You can specify the addresses that it has local to the machine, and then just supply a NixOS configuration essentially within the block itself. And then it will provision a self-contained NixOS distribution essentially in the file system, and mount that, and then essentially change root into it. And so from that you can get you can essentially get isolation primitives, where you can have multiple concurrent containers, and they can allocate their own services, the duplicate services on the same ports without any conflict. But all in all, they can use different virtual network devices on the same host. So there's no actual conflict there. And so when you're using NixOS containers, they actually show up as systemd services, which you can then start and stop and operate with. And there's some handy commands, just like nixos-containers, start, stop, create, that kind of thing. And it's just a layer of abstraction over systemd-nspawn containers. And so here I've just got an example of 5 containers running concurrently, and they're all actually running a service on port 8080. Now, we can take this further actually, because this is all remote. So if you just want something, excuse me, local to your own device and not networked in any manner, then this will do the job for you. But I was remote and I needed something a little more conducive to my environment. So I wrote a little wrapper above NixOS containers, which I just call Workspaces. And this allows you to provision NixOS containers remotely from a very large DevBox host. And so this is just the help command for it. We've got a client server model similar to Docker. And I'm not going to go through all of these commands here today, just the main ones. But yeah, essentially what you have is you've got your client. So that would just be my laptop. And then you've got your host provider, which all of the containers will be hosted on. And so we've got on our client, we've got some local user, let's call him Bob, and Bob is a member of the Workspace group. And so Bob can access the client daemon, and the client daemon has configuration which knows then how to contact the DevBox host. And then the DevBox host has a service daemon, a Workspace service daemon, which can then receive a request for a new container, provision it locally, and then give back information about the container in order for the client to access it. And so, as I said before, access to the local daemon is gated by access to the Workspace group, similar to how you would have a Docker user group. And so when we want to, let's say we have a running container now using this client server model, when we want to initialize a connection to one of our hosted Workspace containers, well, it just looks like this. It's essentially a 4-step process whereby we have our laptop and its local Workspace client binary that then issues a request to our host, just over HTTPS, um, which requests information about a specific running container, and the host returns the internal IP address relative to that host. And then just using SSH, the DevBox host as an SSH jump box, the client can then jump to the individual workspace, provided that the NixOS configuration accepts their public key for their SSH keys. And so using the DevBox host as a jump box, we can get to our individual workspace. And so we have the stack of technologies that we're working with here, and we're really just, resting on standing on the shoulders of giants. So the NixOS Workspaces relies on NixOS containers, which is actually a Perl script, believe it or not. I was quite surprised to see that, but I maybe shouldn't be. Which then just engages systemd-nspawn, and systemd-nspawn relies on the Linux isolation primitives that I'm sure many of you are familiar with, or at the very least you've heard before, such as namespaces, cgroups, capabilities, and seccomp. And these are all the same technologies that are used in Docker and Linux containers, but it's not the same thing exactly. And so if we want to install it, we've got a client service configuration. We import the package. We supply just a config path, which has some credentials. What user we're going to be using as the jumpbox user, what ports the things are running on. The SOX5 port is actually used as a SOX5 proxy. So if you've got arbitrary, ports opening and closing and local services within the containers themselves that you want to access without having to manually statically forward them, well, then you can make use of the SOX5 proxy. And so using the workspace environment is as simple as, just the workspace create command. We give it a name, that's the workspace parameter, a repository, so a repository that we want to clone and work on as a development environment, and optionally a branch. That will then, provision the container, clone the repository, and initialize a little development workspace using ZeLJ at the moment. Then once that's provisioned, you can attach to it. And so it's very similar to if you were using tmux or ZeLJ. It's just a workspace attach command. You just specify the name of the workspace that's running on the host, and it will go and do the needful. Really, this is just a convenience function over an SSH command using the jump box as the jump box, but it will resolve those internal IPs addresses for you so you don't have to do that. And so when we attach it, this is an example of how I have my setup. You're free to customize this kind of thing. You don't have to use ZeLJ. You're free to use tmux, or you're free to just use a shell itself. You don't have to use any terminal multiplexer. But yeah, this is kind of my setup. I use ZeLJ. It's phenomenal. I think it's a cut above tmux, at least for my personal use. We've got, support for tabs that are very visible. We've got stacked panes and everything. Everything's on a hotkey. It's very, very nice. And so if we're switching between containers during our development workflow, let's say we're issuing prompts to an open code or a Claude CLI instance, and then we want to switch to another workspace that is ready for us to continue working on. But then we want also to get access to the services from our local computer that is running on the container. Well, that's what the proxy is for. As I mentioned before, it uses a SOX5 proxy provided by SSH. And so you can manually select what ports to forward or to remote forward. Yeah, so if you want to, if you attach without providing an argument, it will list out all of the running containers on the, the DevBox host, and allow you to select which one. This is just a fuzzy finder prompt, and then you just hit enter. And then it will just attach to it as I showed earlier, like this. And then you're free to go. Now, this all relies on a couple of changes I actually had to make, notably to nixos-containers, the Perl script. I actually had to add some extra flags and parameters in order to facilitate Docker use inside of the containers themselves. Specifically, they needed the netadmin capability in order to create the virtual tunnel device. But yeah, there's a couple more. But that works very nicely. I haven't upstreamed this patch just yet. I'm probably hoping to do that actually today or tonight. But we'll see. We'll see. Just as a nice to have, there's also a waybar indicator that you can just configure very easily to denote what container you're connected to over the proxy. And if you click that, then it will give you the prompt to select which container you want to connect to. Here's an example of the waybar configuration. See on line 213 onwards. We just supply the workspace proxy -- waybar command, and that will then populate, in the string format that waybar expects. And then we also supply an on-click command for our hyperland waybar configuration, which is just supplied here, and that gives you that nice little pop-up. Now, if we want to take this further, I plan to. It's worked very, very nicely for my needs thus far, but I think my needs are now outgrowing what it has provided thus far. Specifically, I'd like to add, fast provisioning. So you can actually rename workspaces. So if you've done some work and you don't want to, shut down that container and then spin up a new one because it takes some while to fully instantiate the NixOS closure, system closure. Well, then what we can do is we can just, rename that workspace and nuke whatever development environment you are working in. But also what we can do with this is fast provisioning. So we can eagerly provision a new container that is unused. And the moment that we need it, we just rename it to whatever we want it to be named, and then it's ready to go and ready to clone your Git repository. And so, that brings it down from like a couple minutes to like less than a second. It's fantastic. So going back to kind of like asynchronous use, I see a lot of people are very excited about agents. You've got, six prompts going on at once, maybe, I don't know. So I'm working on ACP, like agentic control protocol aggregation. So if you've got multiple instances of OpenCode or Codex CLI or Claude CLI, we can then aggregate those at the point of the dev box and give you one centralized control plane. And then we can actually provide like a web app or some gateway where you can control all of them all at once and see when the next one is needing your attention without having to manually go and attach to those and figure that out. Additionally, something that would be really nice to have is a shared egress gateway, whether that is through like a proxy, a HTTP proxy, in order to collect traffic, if you want log analysis in a centralized point, as well as agentic bring your own keys. It's a little bit cumbersome to get all of your your credentials onto all of the individual workspaces. There's a command to upload stuff, but ideally you would just put it in one location and it would sync and keep up to date. And so having a gateway for that would be nice to have. And yeah, so that's where I'm going with this. If you want to contact me or if you want to follow the development, it's here on the right. The repository is actually just a placeholder at the moment. I have a couple of things I need to clean up from the repository before I publish it. Yeah, thank you very much. Thanks for coming and listening to me today. And may the Nix be with you, I guess. yeah, I'll just leave that up. Does anyone have any questions? Will we take questions?
Yeah, we've got a question from the chat. How is the support for NixOS containers? I'm inclined to choose Incus because of the effort in it. Not sure NixOS containers is getting love or not.
Sorry, Incus? I'm not familiar with Incus, actually.
Googling it. It's another container manager, I'm pretty sure. Oh, it's a community-driven alternative to LXD from Canonical.
Okay, so that operates on the same primitives as LXC, as well as the same isolation primitives. But Linux containers, LXC, Podman, Docker, these are all isolation technologies. But they're Docker, LXC, Podman, they are that management layer, and that's exactly what systemd-nspawn is as well. Now, NixOS containers have the nice integration point with NixOS in that they share the same Nix store. So you're not going to duplicate entries in your Nix store and blow up your hard drive. That's probably the nicest thing there.
Any more questions?